This video explains the example of calculation of the simply supported beam. The simply supported beam has a cross section 700 millimeters by 350 millimeter. Rectangular beam span 7 meter long, simply supported inside a residential building and contain the following reinforcement along the entire length. Now there are compression reinforcement 2 and 20 bars at the effective depth of 50 millimeters. And 4 and 24 bar at the effective depth of 645 millimeters. The top surface of the beam is not exposed to the atmosphere. The beam is required to support the following uniformly distributed surface load. It has dead load of 30 kilonewton per meters, that include the beam self weight, and live load is equal to 20 kilonewton per meters. It has short term factor psi s equal to 0.7. It has long term factor psi l equal to 0.4. Now it asking you to predict the following short term deflections at the level of load will cause the flexure cracking to initiate. So what happens here? This is the load deflection cause as the beam will loaded under the self weight and dead load, that will have immediate deflections. Let's say at A. I think before the cracking it will have B1, and then if you have a beam crack will be B2. And as you know, the beam will also have a bending stiffness between the cracks, that will calculate the I effective, which is B3. Now at the level of load will cause the flexure cracking at the initiation. So we are looking for what the moments that we will get at the point A. Under the short term serviceability load, so under this load, if you substitute Ig, like at Ig, what would be the B1? I cracking moment. So when the beam is a crack at B2, what is the deflections? And I effective would be between the Ig and I crack. It is due to the tension stiffening effect. We will have this effect called it's called tension stiffening effect. Due to tension stiffening effect, the actual curve, this is the actual curve, this deflection curve that you are seeing is actually this actual deflection curve under this loading curve. Well, this is a theoretical one. Well, the cracking moments, when we assume that the beam does not carry the beam under tension does not carry any load, that is I crack. But generally beam will have some bending resistance in the tension side of the concrete, and because of that it has some stiffness added to the I crack. So therefore we need to calculate I effective using the Australian standards. But they have give you the various deflections that will allow us to compare at the different level of the loading in the beam. So as the load is at 0, you have 0 deflection. As the load increase, the deflection will increase in the beam. And these deflections, let's say we are measuring at the mid span. At particular point, when the load reach, it will crack. So that we can calculate the cracking moment at this particular point. And then beyond this one, the beam will crack, and it will continue cracking until it's reached the ultimate point. So in the next video, we will solve these examples. Thank you very much.